Hello there, it's Jay here from Jay's Vintage Junk, and once again we are back on with the Amstrad CPC 464 project. And today we're going to be just having a clean up of the motherboard here. We've already ascertained that pretty much we're pretty sure that there's nothing really wrong with this, but it's filthy dirty. It has one electrolytic capacitor on it, which due to previous bad experiences I'm going to change anyway. No matter if it works or not, I'm going to change that as a matter of course. We don't need to be concerned about these decoupling capacitors here because they're all of a ceramic type, and they very rarely ever cause any problems, especially not at 5 volts in a little DC decoupling roll like they're being used there. I really don't need to worry about them, but we will change that for peace of mind. We'll give the board a really good clean up, and we will sort these edge connectors out here because they're quite badly corroded and they look rather nasty. Right, so let's get started, but before I do, I don't know if you've noticed that I'm wearing. What this is anti-static strap. Now when you're working on any of these old pieces of equipment, any old computer equipment really, you've got to be aware of ESD dangers, basically electrostatic discharge. If you're not grounded and you're messing about with these type of things, you don't actually realise you've done any damage, but you can fry anything on one of these just by handling it without the correct anti-static precautions, which basically is what this is. Now I know you've seen me working on computers before, you've never seen this before. The reason for that is that generally speaking, I don't like the restrictions that these give you around your hands. So I have one of these that I use which goes around my ankle. It's the same type of connection, it's just it's the same lead actually. It's just a slightly bigger one of these, and that just goes around my ankle. It has exactly the same effect, it just grounds you out. And the other end of this is connected to, actually my desolder station has a ground point on the front, and the other end of this is just connected to that, which then just goes to the mains ground. So it means that I can't build up any static on my body and then discharge it through the board and potentially do damage to the board, which doesn't necessarily show up straight away either. You can fry a chip and it keep running for a few months in, like as they've described before, in a wounded state, and then fails 2-3 months down the line. So if you're working on the inside of these, really you should be wearing some form of anti-static and some form of ESD protection. The very pinch, the very least you should do is just every minute or two just touch something that's grounded. Like I'm just touching the case of my bench power supply there. Anything that's grounded, and make sure you keep grounding yourself, but ideally it's not enough that you want an anti-static strap like that. Anyway, enough of that. That's just a case in point. What we're going to do first is we'll get this off the board, we'll get this off the case, we'll get the board out, and we'll start having a look at giving this a clean. Okay, I only had it held in with 2 screws from the last time we had it out when we was originally getting this computer working, but there we go. And the case will go off, and we'll be cleaning the case in the next instalment of this video. But that's it, and as I've said before, it really is very small, the board in this, but we've got it out. And the first thing we're going to do is just give it a really general clean. And what I'm going to use for that is my favourite, cotton bud, some isopropyl alcohol. There are proprietary cleaners you can use for cleaning PCBs. I do use them, but I have run out at the moment, and this is just as good. All we really want to do is just get all the years of accumulated muck and crud and rubbish off this board and get it looking like new again. this is just the first thing to do really when you're cleaning a board up, is get all the years of muck and rubbish off it. Because it makes it so much nicer to handle for the future. It makes it easier to trace, if you've got faults on the board, it makes it easier to trace out circuits. It makes it easier to trace actual tracks out if you can see them properly. Because I mean, look at the difference there. If you notice, I'm purposely not going over the edge connectors at this moment because we're going to spend some special attention on them after. But let's really have a good go around here. You can see all the printing coming up a lot cleaner than it was as well. Look at that one already, that's filthy. Let's get another one. And this shouldn't take too long, it really shouldn't. Unless the board is in a really bad state. That's the processor there, we'll just give that a clean over. Get down in the side there. I believe that I'm cleaning now is the ROM. I'm pretty certain that's the ROM. I would have to get the service manual out to double check actually, but let's get in there. Get in there. That's basically like your version of the ULA, I think. It's like a gate array. Just clean around the crystal. Let's get up in here and get around that transistor. That transistor, incidentally, that's what switches, pulls the tape ground low, I believe, from looking at the circuit diagram on this thing. So if you have a fault where the tape's not running, and you've tried what I've shown on the tape player, running it externally and grounding it out, and you know the tape player works, but when you press play, you're still not getting anything on the you're still not getting the tape motor to run, then my next port of call probably would be to test that transistor there. Let's have a good scrub around here. Sometimes you have to go back over places you've already been because you've missed a bit. Like I say, I want to get this as nice and clean as we can. Get in there, get between all the chips. If you have to lift the component to get in, do so, but just be really careful while you're doing it. Right, that's... I'm sure I've cleaned on top of there before, but let's give it another little scrub. And let's turn this board around. Yeah, there, that's good. That's another one full of crud. You do go through plenty of cotton buds doing stuff like this. And again, let's just finish cleaning the board up. There we are. That's looking tons better. There we are. I think that's about there for cleaning the dust and the general grime off it. Certainly looking better. Let's get some off that connector there. Get a bit in there. Right, so we've got it all off like that. Next thing I'm going to do, basically what I showed on the last thing with the tape player, is I'll get a piece of paper and I'll just fold it. I'll fold it that way. Fold it like that. make a bit of a shim out of it. I'll get some isopropyl on there. Just let a bit of that evaporate off. Let that soak into the card a little bit. And all we want to do is get it in these edge connectors. Just push it down in there like that. Pull it back out. Push it down. Pull it back out. Push it down like that. So it goes into the edge connector. Just pull it back out. And again. Push it down, pull it out, and as you can see, you just get all the crud out of the edge connector like that. And that should, I mean, it wasn't causing a problem, but it's good while we're in here just to do that anyway, get any crud out of there. And next what we will do is we'll just clean up these connectors at either edge. You know, we'll do a bit more isopropyl on here, but we'll spend a little bit more time on these than we have on the rest of the board, because these are really badly tarnished. They're absolutely filthy. The one thing you do not really want to do with these is get some emery paper and start scrubbing away at them, because all you'll do is you'll take the plating off, and it's not necessary. 9 times out of 10 at least it's not necessary. There are exceptions where you might want to use something that's very, very, very lightly abrasive, but that is really the exception to the rule. 9 times out of 10 this is all you need to do. And as you can see how filthy that connector was when we started and how it's come up now. There is a slight bit of corrosion just there on that one pin. I'll just point to that, literally just there. So all we'll do with that is we'll just get a little jeweler's screwdriver and then just really gently just rub away at that little bit of corrosion. Quick rub over with the isopropyl again, and that's pretty much gone now. There, that's that one done. Then we'll move on and we'll do this one along here. Exactly the same technique. We'll just rub up and down them, and you can actually see the oxide lifting off. Now that's no good. Now we'll get another cotton bud, just moisten up another cotton bud, and we'll carry on. I think these two connectors, one's for the disk drive module you can get for the 464, and the other is a printer interface. So yeah, possibly for the disk drive connector that may get used nowadays. The printer one not so much, if you're just going to be playing games on one of these things, but it's still nice to have it functioning. And you can see how much crap's just come off that. There we are. That's nice and clean now. Give that a quick last wipe over, and then of course we need to on these do the same on the other side of the board, which will only take me a second. Because this isn't anywhere, obviously with it being on the bottom of the board, it just doesn't get as dirty. It's not got stuff settling on it as much as it would on the top. But they've still got some tarnish to them. It's probably from it being stored in an attic for years. So they still just need a good cleaning over. Like that. Let's get back on, let's do this one. I mean, you can see straight away that there's not as much muck and rubbish coming off these from underneath. It was the ones on top which were filthy dirty, but just as well just to get them clean as we can. There we go. I'm happy with them now. So that's the edge connectors cleaned up. They've still got a little bit of tarnish on them, but they're certainly usable now. yeah, no, I'm happy enough with them that they'll make good contact now anyway. They were just dirty. Next thing we're going to do is we're going to change this capacitor here, just for peace of mind, because it's a 30-year-old, well, nearly 30-year-old electrolytic capacitor, and in the best will of the world, if it's not going to fail next week, it'll fail in the next year or two. It's if this computer is going to be put into fairly heavy use anyway, so we will change that for peace of mind. This board, incidentally, let's see, you can usually date a board. I mean, it's got a design date of 1988 on it, but the best way to usually date a board is have a look at the date codes on the ICs. So if we look here, we've got two RAM ICs, haven't we? They should be easy enough to date. Yeah. These have all got date codes of 1990 on them. So we can pretty much deduce from that that this one was made, that's got 89 on it, but they're 1990. The CPU's 1990, the RAM's 1990, so I think we could pretty much deduce this one was made in 1990, which would make it one of the very last of the CPC 464s before the 464 Plus came out, of course. Anyway, what we're going to do is change that capacitor, and what I'm going to do is I have a fancy, very old, virtually antique, but still quite fancy Weller desoldering station, a vacuum operated Weller desoldering station. I'm not going to use that because most people doing this probably won't have one of them, so I'm going to do it the old-fashioned way. We've got a rather cheap desoldering pump. These can be picked up in, they're about £5 or £6 I think in Maplin's, but they're like £1.50 on eBay. So that is like your minimum that you need to do this kind of work. So we've got a desoldering pump, we've got some liquid flux and a flux pen, we've got some good old-fashioned 4060 lead tin solder, none of this lead-free crap. We have got, let's just get this out. It's snuck into the inside like these horrible things do. There we go. What this is, that is some desoldering braid for cleaning it up if we need it. And we have a fairly cheap Maplin's temperature control soldering iron, which to be fair is perfectly adequate for this kind of work. What I will just quickly do, because I've just realised I haven't done it, is just dampen my sponge so I can clean the tip off properly. So we'll just moisten the sponge a bit. I can prepare my tip on my soldering iron. We clean it and we take a bit of solder. Just tin the end up like that, and then we can put it nice and neatly back in the eye in its holder. Right, now the component in question, and I have its replacement here, is a 4.7 UF, it's rated at 50 volts. I think that's pretty much because in these low UF values, electrolytic capacitors, unless it's something specialist, 50 volts is about the lowest they go. It's only ever going to see 5 volts or so, so anything over, say, 10 volts will be perfectly adequate. Right, anyway, fortunately this board's not too bad. It's actually marked what the capacitor is. The capacitor is marked by that little line there, and we can see that one there has a plus on that side. And we go over to it, that is that capacitor there. And what we're going to do, I'll just show you how we remove one using a desoldering station, a desolder pump, a hand operated one rather than my desoldering station. And the first thing I'm going to do is just add a tiny bit of flux to the board round where we're taking the old component out. The next thing I'm going to do, and this might seem a little bit odd, is I'm actually going to add a tiny bit of new solder to the joint. Only a tiny touch, because that will just help the old solder as it ages. It tends to crystalline a little bit, and just adding a little bit of fresh solder it makes it flow a little bit easier. Same as with adding the little bit of flux to it, it just helps the solder to flow. And what we want to do is heat the joint up. While the joint's hot, bring the sucker in and pop. And that has taken probably most of the solder away from that connection there. Just clean the iron off. We'll add a tiny touch of solder to the end of the iron again. Now the next leg isn't quite as easy because it's actually bent over. So what we're going to do is, before we try and suck it, we'll just heat it up and see if we can just straighten that leg up a little bit. This is not that easy to do, but sometimes you can manage it. There we go. Let's just straighten that leg up, which will make it just that a little bit easier to get out. And we'll add another little bit of solder to that one. This one's going to be a little bit trickier, I think, than the other side. Add a little bit of solder to it. Oops. Heat it up, go in with the sucker and suck. That's got most of it out. There we are, that's straightened up nicely now. There we are. Now we'll have one final suck at that one. Then heat it up, go in with the sucker and suck. There we go. Now that's got most of the solder off from there. If we bring it back over and we just very gently just play with the component a little bit, just make sure it's actually free properly from the holes, because we don't want to pull the plating out from in the holes. Now that side there is perfectly free. Now this side is seeming a little bit more stuck. And what it is, it's just a little bit of solder that's on the end of the leg there that we took out. So what we're going to do is just gently wipe it like that. Just get rid of that little bit of excess solder. And hopefully now, when we pull it out, there we go. That's the old capacitor out. As you can see, there's nothing nasty on them legs. We've not lifted the through-hole plating in there. That's nice and clean. We'll spin this back over, and all we want to do is we just want a clean round there with a little bit of solder braid, just to make sure it's all nice and neat and tidy before we add the new component. So if we get a little bit of solder braid, solder wick, solder braid, it's the same stuff. And what I like to do is just add a little bit of extra flux to it, like that. We take this, we get our iron, and all we need to do is just hold that over like that, just go over the joint, get rid of any excess old solder. We will take our new component. We need to observe polarity, so we know that that side there that's indicated with the little cross is the positive, and on these capacitors negative is marked, so we know if we put the side that's not marked in the positive hole and the side that is marked negative in the hole that isn't marked, we should be right for that capacitor. So we put it through the board like that. Then all we need to do is just solder it into position. So we come in with the iron, heat the leg and where we're soldering up, pull it away. That's the first connection made. Again from this side, just go in, heat it with the iron, and that's the second connection made. Just a tiny bit more solder on that one. There we go, that's perfect. That's perhaps a little bit too much solder on that side there. I've just come through with it. I must say actually the holes were rather large for the side of the capacitor, so there's a little bit of solder leaked through there. All we need to do, if we go in with a bit of braid, we can just whip that away like that, and as we see, that capacitor is nicely in situ there. All we need to do now is just trim these legs off, of which I will use my new snips. Got some new, only cheapy, only a couple of quid, but these, I'm just trying these. I've used these type for years, but I saw someone else on the web using these, so I thought I'd give them a go. And there we are, that's perfect. We have got a little bit of flux residue on that side now from doing that, which we can easily remove. So what we do, we just go in with the old cotton bud again with a bit of isoprop on it and just clean up the flux residue that we created then while we were soldering. There we are, we can see that's come all clean again. Some people don't bother doing this, but if you leave it, it just goes brown and sticky and horrible, and it looks really messy on the board. And for the 30 seconds, a minute it takes you to clean it off, why the hell not? There we are, as we can see there, that is where we have replaced the capacitor. If we look on that side, that is the new capacitor in situ. If we look at the board is now nice and clean. So until we get to reassembly and testing this thing, I'm happy with that board now. That won't be going back in the case for now, that'll be going in a little storage box until I'm ready for it. In fact, I think I've got one up here I can use, yes I have. I will put that safely away for the time being. And the final thing we will do in this installment is I will just get the keyboard out, and we will strip this down and get it ready for cleaning. Now this is going to struggle to fit this in shot, I think, but let's see if we can do a bit better than we have. Yeah, there we go, that'll do for now. Right, so there is nothing wrong with this keyboard, we'll say that straight away. It doesn't actually need any work on it, but it is really dirty. Now we could, at a pinch, clean it like this. We get isoprop, we get it on a cotton bud, we push down the keys and we clean each key like that individually. But even doing that, you can't get in there to clean in there. You can get most of the crud off, but it's really time consuming and you won't do a brilliant job. You can see the crud that's just come off there already, because it's stuff from fingers and it's just horrible. So what we're going to do instead is we'll release these clips. Got to do this carefully because we don't want to risk breaking any of these, but basically you just pop them off like this. Now this does look like it's been bent at some point, so we can straighten that out while we're working on this as well. I haven't actually noticed that before, but yeah, it does appear that the keyboard is slightly bent, which happens with things that get thrown in attics. I've certainly found these and Spectrums and things with bent plates on them before. Let's get that off. yeah, that's actually, if we look at that, that has had a bash at some point, so we will straighten that up as part of the repair. Now the next thing we're going to do is we very carefully remove the membrane. That we will be cleaning in a moment, and fortunately, yeah, the springs are attached in one of these, but that now we can put in the wash with the rest of the plastics, and we can get all the crud off that. We can give it a really good scrub, and we can get that like new, but that is for the next video. We'll just get that out of the way for the moment. We will I will just try and find some new clean paper to go down on the bench while we do this next bit. I should have some somewhere around here. I forgot that we can use. I have to apologise for the fact it's white, but we'll put that down like that so we can see what we're doing. We've got a little bit of tissue paper here. You don't really want anything more than like just a bit of tissue paper. And we can just lay that down, and we can just give it a good wipe down and just get all this years of muck and rubbish off this membrane like that. If we actually look at the membrane itself, it's actually in absolutely fine condition. You can look at them, you can tell when they're starting to go, because you'll see like whiteness and blotchiness on the tracks. And as you can see, this one, it's nice and clean still. It's actually in good condition. That the tails aren't going brittle or anything. They've still got plenty of life in them. They're still nice and flexible. So I'm not worried about that. Obviously you do have to be careful with them. I'm not 100% sure whether you can get replacements for these at the moment. I'm sure if there was enough demand, then someone would remanufacture them like they have with the with the Spectrum ones, with 48K Spectrum ones. So if that comes a necessity, I'm sure someone will look into doing it. But that is now clean and ready to be used again. That I'll probably take down to my workshop and straighten, unless I can just, I wonder if it will just bend straight now. Let's give it a, oh, look at that, it was actually just with a little bit of brute force and ignorance over my knee. Yeah, I've got that as straight as damn it, just by manipulating it over my knee, so we don't need to go any further with that. It just needs a little bit of a clean down. So I will leave it at that for this video. Hope you found that useful. And in the next video, we will be cleaning all these plastics and getting all the paint off it. See if we can sort any of the little blemishes out in the case, and then hopefully in the final instalment we'll be putting it all back together and having a nice fully working computer. So I'm going to leave it at that for now. So thanks for watching, and goodbye.